Hey, we need Formula One start lights. We are really hard working implementing new cool features. Can you imagine that the functions of the coolest lap counter on the web are not complete? I mean, seriously, the thing has already a number of interesting features, especially considering it's a DIY project. Actually, you can use the lap counter very well as it is. However, we had additional cool ideas while playing with the racetrack and we decided to implement them. If you don't want to be infected by our enthusiasm, then you must not look this video any further. There were a lot of new ideas that I will definitely let you know when we realize them. The most burning desire was improved starting lights. Okay, and how should they look like? Of course, like Formula One was the answer. Yes, we need Formula One starting lights with the corresponding start features. However, we will see in a minute that the software alone is already quite a bit complex. In addition, before implementing it in the code, I need to check whether the electronic hardware could be expanded accordingly in order to control that many LEDs. The ESP32 is versatile and powerful, but sometimes there are limitations when using the pins. We had already seen this in a previous episode, when I had to change the connections for the relays so that the serial port would work properly. My concept now is that I control two LEDs with one output pin. This means I need 10 additional pins to control the total of 20 LEDs. Please forgive me, I didn't show the 20 series resistors here. The piezo buzzer, which I haven't mentioned yet, of course also requires an additional pin. I mounted the 20 LEDs, including the 20 series resistors, on a universal circuit board. These parts are good for testing, but it would have been clever if I had designed a printed circuit straight away. I could have had a printed circuit made by PCBWay, the sponsor of this video. They are offering that service for a fair price. Just take a look at PCBWay's website before you start your next project. The company covers a comprehensive portfolio of products and services. Besides PCBs, they are offering 3D printing and CNC, including services. Each of the 5mm LEDs draws a current of approximately 6 to 9 milliamps. The brightness of the LEDs is absolutely sufficient, as you can see. Since a maximum of 10 LEDs can be on at the same time, the total power consumption of the LEDs is approximately 60 to 90 milliamps. The buzzer, which I should rather call a beeper, consumes about 20 milliamperes. I'm using a 50 ohms series resistor in order to limit its current and its volume. Talking about power consumption, let's briefly estimate the total consumption, because we haven't talked about that yet. The two relays each draw approximately 60 milliamps, totaling 120 milliamps, which is supplied via the 5 volts pin, not from an ESP32 output. One IR sensor board draws around 30 milliamps, totaling 60 milliamps, which we feed via the 3.6 volts pin. The ESP32 processor board itself draws an average of around 100 milliamps. The current peaks of the processor board are certainly closer to 200 milliamperes or even higher. Altogether results in a maximum consumption of around 390 milliamperes. Of this current, 180 milliamperes flow via the voltage regulators on the board, and the rest, 210 milliamperes, flow via the ESP32. I tested for hours to see if components on the board are getting hot, which they didn't. The average consumption is less than 300 milliamperes, which is what every USB output of a PC or power bank and almost every standard USB charger can deliver. Since short peaks up to 490 milliampere can occur, a stabilization capacitor for the two supply voltages is definitely worthwhile. I hope that I have now connected all the hardware that we might need in the future. We can control the LEDs and relays flexibly, so that we can implement new features via the code without changing the hardware. For now, we have two additional features on our list, and I have to explain to you how they actually work, because there is more to it. When switching on or after a reset, all red LEDs initially light up and the two relays interrupt the power supply for the tracks. While the start function is running, the two relays switch on the power immediately, and every second two additional red LEDs are going out. This is also indicated by a short beep. In this phase, an early start is detected by measuring the voltage on the tracks, and our counter then computes penalty times for the early starter. The penalty time corresponds to the time someone tries to drive already during the stop phase. You could tighten the feature, and the penalty time could, for example, be increased by a factor or simply added a few additional seconds. At the same moment that the two last red LEDs go out, all green LEDs light up and you hear a longer beep. And this gives the drivers a visual and an acoustic indication to start the race. On the web interface, the user can observe a countdown during the start sequence. Okay, this is exactly the starting lights procedure with early start detection that we wanted. A referee could stop the race and restart it if he recognized the penalty time at the start. If the race is interrupted by the stop function, the relays are breaking the power supply and 10 red LEDs instead of 10 green ones light up. Additionally, all counters stop and we get a long beep. As soon as we want to continue the race, we use the start function again. This time there is another long beep, but the traffic light immediately turns green and all counters continue to run. To start a new race, press stop, then reset. Now you could change the number of laps in the race, and at start, the start sequence begins again. We are now talking about code version number 3.3.2. I always specify the version number, and this is then displayed in the web interface. In our main program, we call the start sequence, which only gets active under the conditions just described. Let's take a look at the subprogram for this. Here we have the subprogram for controlling the LEDs and the relays in racing mode. And then we have the start sequence, where we have to check a whole bunch of conditions for the sequence to be activated. Among other things, the complexity is driven by the fact that you need to control various time counters. The F1 start light looks really cool. I think it was worth it to postpone the housing a bit. Not only does it add more racing atmosphere, it is also really practical for starting the race without having to make any complicated entries. The start of a real Formula 1 race looks a bit different, I know. 5 red lights are switched on successively, and when they all go out at the same time, the race begins. With a few changes in the code, this could be also realized with our electronics. However, we were in favor of controlling the lights the other way round and to add green lights. The control of the LEDs and relays is quite flexible, so you could also implement other new features in the code. And we are still having a lot of ideas. If you have any input, please let me know. Maybe it can be realized. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.